Imagine a tiny dot tracing invisible lines high above our heads, performing its intricate dance. Have you ever wondered what dictates its precise path, or why some satellites seem to fly over your home daily while others rarely do? Orbital inclination is a fundamental factor that significantly affects a satellite's ground track, determining which parts of the Earth it can observe and how frequently. It is the angle between a satellite's orbital plane and the Earth's equatorial plane, and it defines the maximum latitude, north and south, that the satellite will pass over. The Earth rotates beneath the satellite's fixed orbital plane. So, a satellite in a low inclination orbit, close to the equator, will primarily see equatorial regions. Conversely, a satellite in a high inclination orbit, approaching 90 degrees, will cover nearly all latitudes from pole to pole. This difference in angle dictates how much of the Earth's surface intersects with the satellite's path over time, essentially mapping out its territory from space. It is a critical design choice for engineers selecting an orbit for a specific mission. Understanding inclination helps us categorize orbits and predict coverage. For instance, many communication satellites need a low inclination to stay over populated equatorial regions. Weather satellites or Earth observation missions often use polar orbits, which have inclinations close to 90 degrees, to provide global coverage as the Earth rotates beneath them. Observing a satellite's ground track can help you infer its purpose. Wide global coverage suggests a high inclination, while consistent passes over a narrow bend hint at a lower one. One fascinating application of inclination is the Sun's synchronous orbit. These are specific high-inclination orbits that allow a satellite to pass over any given point of the Earth's surface at the same local mean solar time every day. This consistency is invaluable for imaging satellites, ensuring consistent lighting conditions for repeated observations, which is a key advantage for monitoring changes on Earth over time. In essence, orbital inclination is the invisible hand guiding a satellite's perspective of our planet. By controlling this angle, engineers precisely tailor missions, whether it is to provide constant internet to specific areas, capture daily global weather patterns, or track environmental changes with perfect lighting, ensuring each satellite fulfills its unique purpose in the vastness of space.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.